Well, welcome everyone to today's webinar on teaching exploratory data analysis. My colleague Ross Matusalem will be doing the presentation today. For those who come to our webinars a lot, you know that Ross delivers excellent webinars, a lot of great useful information. I always learn a little something myself. And so, a couple things. There's a poll up on the screen. We'd like to get just a little understanding of your experience in JMP, or if you're brand new to JMP, not currently a user. There is a Q&A window, so if you have a question, type it in there, and I will be answering them live as they come in. We may also wait till the end of the webinar to answer them. We'll see how the questions come in, and occasionally I might ask Ross to answer it in the moment or redo something if that seems like the best thing. But type your question in the Q&A window. There's also a chat window. You're welcome to make comments in there if you want for not just us, for the broader audience. But it's better if you have your questions in the Q&A window because it will be easier for us to manage and make sure every question gets addressed. The webinar is scheduled to be about 35, 40 minutes or so. And we're doing that so we have a lot of time at the end to answer questions. So when Ross is done with the formal presentation, he and I will hang out, answer any questions. I don't have a meeting after this, so I can actually stay as long as anyone wants. Um, and as always, feel free to reach out to us afterwards. We're happy to support you in any way of using JMP. If you're interested in a custom webinar for your colleagues in your department, let us know. We'd be happy to organize a special one for your department using the kinds of data that you would normally see and what kind of topics make the most sense for your department. So please don't hesitate to reach out. So with that, let me check in, Ross, if you are good to go.
Sure am. Thanks, Kevin. And everyone, thanks for joining to talk teaching exploratory data analysis with JMP Student Edition. So, uh, if you've come to our webinars in the past, our teaching focused webinars, we often talk about teaching a particular technique or collection of techniques. In fact, coming up later in this semester, we have teaching regression in ANOVA and teaching design of experiments. What we're talking about today and what we're going to do is a little different because we're not talking about teaching a technique as much as we are about teaching a process. So for those of you, and I see in the poll, we have at least a few who aren't too familiar with exploratory data analysis. The whole idea is that you take a data set, you ask some basic, oftentimes pretty high level question, use some kind of simple graph or summary statistics or basic analysis to get an answer, and then you use what you learned from the data to help form a new, more focused question. And you just iterate on this until you discover something useful. So you basically let the data kind of guide you down a path towards knowledge. So why teach EDA? It's not really a traditional component of most statistics education, though that seems to be changing. You want to teach it probably because it's a more real world application of data analysis. So outside of the true hypothesis driven research that's typical in academia, people don't too frequently get a data set and just perform one definitive analysis and then they're done. They explore, they seek patterns, they try to derive useful knowledge from their data. And when students enter the real world, they of course may sometimes be given a data set and then asked, hey, do a regression on these variables and tell me what the relationships are. But oftentimes a manager might hand them a data set and say, what can we learn from these? And that's where exploratory data analysis becomes critical. So why teach EDA with JMP? Well, to borrow a saying from a colleague of mine, JMP's interface allows analysis at the speed of thought. So that is, it's so fast and interactive and easy that you can ask and answer questions with graphs and analyses about as fast as you can think them. So let's just take a look at a quick example to make that idea concrete. The data that we're going to work with right now come from a case study that I'm going to review with you in just a moment. But the basic idea is that we're looking at the abundance of fish in the Mesoamerican reef. So this is a barrier reef along the coast of Central America. It's actually the largest barrier reef in the Western Hemisphere. And so we have data spanning from 2006 to 2018 on a number of different subregions of the reef. And then we have fish biomass, so total fish, and then by a number of different types of fish like angelfish and barracuda. And this is measured in grams per 100 square meters. So let's say, we have data like this, and we have a very broad question, just has fish biomass been trending up or down? So JMP's interface, and we'll talk about things in detail in a moment, but JMP's interface allows you to conduct analyses and build graphs really quickly and easily. So in just a couple clicks, you can get to a quick answer. So here, I've created just a line of fit over top of all the biomass values across the years, and it seems like maybe we have a slight increasing trend. I also notice, as I see that, a number of potential outliers. So look, we have some really high biomass values for some of these years at least some of these sites. And when I select them, they're selected back in my data table. I can just quickly create another graph or analysis to figure out which sites those particularly high biomass values come from. And it looks like, just to point out one right here, Cayos Cochinos, where most of the data we have there actually among these outliers. So ask another question. Okay, what does the trend look like specifically in Cayos Cochinos? Well, JMP's interface makes answering that question quite easy. So here we go. We've just updated the graph, and it actually shows a potential negative trend. So a slight decline in biomass in Cayos Cochinos. Though, of course, we're just dealing with a few data points here. And in fact, this most recent one in 2018 might really be influencing this line. So we can ask the question, what happens if that point weren't there? And again, JMP's interface makes it really easy to just get rid of that point and see that, oh, okay, really, I don't know if we can make too much, uh, with respect to this trend in Cayos Cochinos based on the data that we have. Now, the point of what I just did was not to teach you how to use JMP, but to show you, again, starting with a question and using JMP's interface to just make some graphs and interact with the data allows you to very rapidly iterate until you learn something. So what we're going to do today is review core features of JMP's interface that make EDA easy. So that is components of the interface that are all over JMP, no matter what graphing or analysis tool you're in. We'll also talk about foundational JMP tools you should know if you're teaching EDA, so specific graphing and analysis tools. And we're going to do that in an exercise in EDA itself on this data set. Now, you're all going to receive a link to the recording from today and also my JMP files that I'm showing you. And in this JMP journal file that I have right here, you'll find a link to the case study in our JMP Academic Case Study Library that we're basing our webinar on today. So this is case number 62, monitoring fish abundance in the Mesoamerican Reef, which we created in collaboration with Melanie McField from the Healthy Reefs for Healthy People initiative. So Healthy Reefs is a group of marine scientists dedicated to monitoring and improving the health of the Mesoamerican Reef. And so they provided us with a data set where we can examine changes in fish biomass over time in different regions of the reef. And so you can, on your own, have a look at the background of the data and the Mesoamerican Reef, and also an exploratory task where we're just asking students to identify changes in fish biomass over time in different subregions. And then go ahead and click the link to download the PDF of the case study itself, which sets the stage, explains the data. So here we have a data dictionary, and then walks students through an exploratory data analysis path, leading to multiple graphs, answering different questions until we eventually land at some final insight. Now, I'm not going to work through this whole thing in front of you right now. I don't think that's a great use of our time. I also don't think it would be the best structure for presenting you with the knowledge you need to use JMP effectively. But we are going to do another exploratory exercise on this data set right now. So with that, let's get started. And we're going to start actually with the most basic question of all that I think almost every EDA exercise should start with, which is just getting to know the quality of the data itself. So in this case, we have data from 2006 to 2018 in a number of different subregions. Do we have data in each subregion for each year? Basic question. We also see this column here, number of sites. So each one of these biomass values, again in grams per 100 square meters, is an average across multiple sites surveyed within each subregion. So we can see here in 2006, Cayos Cochinos, the values that we're seeing in biomass are averages across 8 sites surveyed. Now, that's a lot smaller than right here where we surveyed 36 sites, but much larger than here with only 2 sites, where having surveyed only 2 sites, maybe these aren't quite as reliable estimates of fish biomass. So let's assess data quality here. And in doing so, we'll take a look at the first foundational JMP tool that you should know for EDA, and that's the distribution platform, which you'll find under the Analyze menu. Now, when we go through these JMP tools right now, I'm not going to give you full tutorials on how to use them. We have many, many support and learning resources that you can use to learn these tools in greater detail, including by following the links to the documentation for each tool that I've provided in the journal. But that said, let's get into the distribution platform. And as I note here, it's a great starting point for any new data set because it just produces all univariate graphs and analyses for us, help us assess data quality, among other things. So I'm going to go to Analyze Distribution. I'm just going to put year, subregion, and number of sites into the Y columns role and click OK. And right off the bat, we can start to see some interesting things. So let's take a look at the histogram here for year. We can see that we have data in 2006, then again in 2009, though we have fewer observations, that means fewer subregions. 2011, 2013, 2016, and 2018. So the data is not distributed quite evenly in time, though it's not too bad. And we don't have the same number of subregions in each year. Now, one thing that's really nice about JMP's interface, and this is the first foundational part of the interface to know, is that everything is linked together. And by that, what I mean is if you select data in one place, in a graph, in the data table, it's going to get selected everywhere. And what I like to tell people is that if you see something interesting in a graph, just click on it and look around because you'll be able to start spotting patterns. So for example, I notice in the bar chart for subregion here that I have relatively few observations for Banco Chicharo. And if I click right on that bar, I can see the Banco Chicharo observations highlighted in the other graphs. So back in the year graph, I can see, okay, it looks like I have one observation in 2006 and one in 2018. So those are the 2 observations reported here in this table. Okay, so we only have 2 years worth of data, but at least they're spaced far apart. So in that particular region, we can probably assess change over time. East Coast Honduras, also only 2, but they're also spaced out in time reasonably well. What about Swan Islands? Oh, well, it actually looks like our 2 observations for Swan Islands are right next to each other in 2011 and 2013. So, I'm not sure that I want to include Swan Islands if I'm exploring the data to try to figure out how fish biomass is changing over time because I don't really have a good time window. So that gets us to the next step now that we've learned something about the data, and that is maybe deciding what data to analyze and what not. Or to put it in more formal terms, we need to filter or subset our data. And JMP has some great tools for dynamically filtering or subsetting. And we're going to take a look at one right now called filter views. So I'm going to highlight that and just cross out this right here, which you can ignore. We'll get there in a moment. I want to get back to my data and just exclude Swan Islands, that subregion, from further analyses. As of version 19, we have a new great way to do this kind of dynamic filtering on your data table itself. So instead of creating some kind of subset data or removing or deleting the rows, you can dynamically filter the main data table by going up to the column you want to filter on, clicking the little filter icon, which pulls up something we call a filter view. So I have my filter by subregion on the left, and you'll notice as soon as I click on any subregion here, it displays only the data from that subregion. And now any subsequent graphs and analyses based on this table will reflect only the data that I can see. But you'll notice if I click clear, none of the data is gone. It's just a view of my data of a particular subset. So what I'm going to do is highlight all the regions except for Swan Islands. Looks like I'm down to 95 rows out of my original 97. And you know what? For our purposes here, I'm actually going to filter also on that n sites variable and say, I only want to include any of these biomass estimates where they're at averages across at least 5 sites that were surveyed. All right, so now we're down to 81 visible rows. If I pop back to my distribution output here, you're going to notice something. Well, one, if you're following me, I just filtered my data table. I probably want this report I'm looking at to reflect the data currently being displayed to me. And JMP will handily tell me with this little icon that the report and the data table are out of sync. So I can go ahead and click on the icon and just ask it to sync to the data table changes. And now it's updated based on that filter I just implemented. And now that I've taken a step, I notice something else interesting. Central Quintana Roo now only has 1 row of data in 2006, and East Coast Honduras only 1 in 2016. So really, I might want to iterate and go back and remove Central Quintana Roo and East Coast Honduras just to ensure that we have at least 2 observations per subregion. And we can see Banco Chicharo, which we saw before, still there with 2006 and 2018. So here we've assessed data and integrity in some sense quite easily. We've actually made some decisions about data to include or exclude from future analyses. Let's take a look just to confirm the results of what we've done here, the filtering. Because if you notice, while we can click around and see, for example, which years we have data for, we don't have a direct way of looking at for each subregion, say, what's the minimum and average number of sites for that subregion and what years exactly do we have data. So I'm going to introduce you to another tool now where we can start to create custom summary tables or cross-tabulation tables to answer questions like that. And this tool is called the Tabulate platform. You'll find it under the Analyze menu. And so what I'm going to do right now is check by subregion. So I'm going to drag subregion into the drop zone for rows. And I'm going to take a look at the number of sites for each. Now you'll notice it's presenting just the sum total number of sites. But I have all these different statistics in this list right here that I can put into the table. So I'm going to say, what's the minimum number of sites for each subregion? So I'll just replace sum with minimum just to confirm that it's 5 or greater. And it is. In fact, the minimum for Central Barrier Complex is a pretty robust 11 right here. I could actually ask for the mean as well. So I'll just place that right next to minimum. And now I can see the mean number of sites for each subregion. If I want to add year to the table, I can just drag that over and quickly ask questions about the year. So what's the minimum, maximum, and range for the year values? And thankfully for us, after we filtered our data, the minimum year is 2006, the first year of data. The max is 2018, the most recent year of data, which is a 12-year range for all of them. So tabulate is a way when you need to create a quick cross-tabulation table to answer some basic questions, just some basic summaries here. You can just drag and drop your way to your answer. All right, so we've learned some about our data, what data we have and don't. We've made some filtering decisions and confirmed the results of those decisions. Let's get back now to the main question, which is, how is that fish biomass changing over time? Now, before we do, one thing I should mention with respect to the filter views is that sometimes you want to save these filter views that you've created. You can always click the Save View button right here, and I'm just going to name this something, My Filter. And you'll notice now in this Filter Views tab in my data table, this My Filter View lives. I can click Exit View to get back to my full data table, all 97 rows. Oop, I actually have 1 row excluded here from working with this previously. Let's bring that back in. And then I can click on my filter just to reactivate it at any time. I'm actually going to delete this one because in the version of the data table I'm working with, I've already created that filter and called it sufficient data. And you'll have that in the version of the data set that we provide to you after the webinar. Let's just collapse the filter for now and get back again to that main question, which is, how is fish biomass changing over time? And to answer that, we're going to take a look at the third tool to know for EDA, perhaps the most important one of all, and that's Graph Builder. which is a general purpose drag and drop graphing tool that if you are a JMP user, I hope you're already familiar with. But here's how it works. If you go to Graph and Graph Builder, you just drag and drop your variables to the blue drop zones that pop up when you start dragging. So in our case, what I might do is put year on the x-axis and total biomass on the y-axis, as we did previously. Now, JMP creates a default graph, but you can change the type of graph by making selections in these icons at the top. So for example, maybe I want actually just a line graph to summarize the trend. And maybe I want the points to be in that graph. So I can shift and click or even just click and drag the points onto the graph to get an idea. And so here's an idea of the trend. So the line is representing the average biomass in each year across all the subregions measured. And we can see it increased a little bit starting, in 2009, going up to 2013, leveled off, and then maybe fell in 2018 a bit. And as we saw before, again, graphs in JMP are interactive. So I see those interesting outliers as we did at the outset today, and it's easy for me to just select them, make another graph to see where they come from. Now, instead of zeroing in immediately on any individual subregion, as we did in the first example, let's actually just bring subregion into the graph. I'm going to put it in the wrap role, which creates a trellis plot. So now I have one plot per subregion, and we can start looking to try to find some patterns. For some of these, it looks like, there's a fair bit of noise. So central barrier complex, for example, it's just going up and down and up and down. So maybe some natural variation, but not a clear trend. Now that contrasts with maybe Cozumel, which seems to have a clear positive trend. Same with Southern Quintana Roo, maybe Lighthouse Reef. And so now in just looking at changes in biomass across time, I'm starting to notice a few subregions of interest. And maybe I want to drill down into just those subregions going forward, ask questions of only those. So that gets us to the other filter mechanism. So we already saw filter views, and that's for filtering your main data table and having all of your subsequent work obey the filter. What if you only want to filter inside a graph or analysis? Well, for that, we have the local data filter. So the idea with the local data filter is inside your graph or analysis window, you go to the red triangle, go down to local data filter, it lives near the bottom, apply your desired filter criteria. So in this case, I want to filter by subregion. So I'll select subregion in the list and click plus. And then I can select any subregion or collection of subregions to have them included in just this graph without affecting the underlying data table. So we saw, for example, Southern Quintana Roo had a nice, relatively steady looking increase, and now we can zoom in on that. Looks like in 2006, Southern Quintana Roo had just shy of 1,300 grams per 100 square meters in total biomass. But a little bit later, 2013, about 3.5 times that much at nearly 4,200 grams. So a really pretty remarkable increase over a 7-year time frame in biomass. And so we could easily just update our graph to inspect all of these subregions however we like using this local data filter. But now we've learned something about Southern Quintana Roo. I want to know what's going on, what was driving this trend. Let's ask another question. This time I'll say, well, do all of the individual fish types, angelfish, barracuda, parrotfish, wrasse, are they all showing this kind of trend? Or maybe some do and some don't. So that gets us to the notion of exploring many variables at once, the many variables being the different types of fish we have in our data. And every tool in JMP has what we call a column switcher that makes it easy to do that. So here, just to save some space, I'm going to click Done and move our graph over. The column switcher lives under the red triangle and the Redo submenu. So I'll go to Column Switcher, select the y-axis column that I want to switch out, then select all of the different columns I might want on that y-axis and click OK. And now I can cycle through angelfish, barracuda, boxfish, butterfly, until I find an interesting pattern. Now, just to cut straight to the point, the parrotfish in this case show a pattern that largely resembles the overall pattern. And you can see that actually in 2006, parrotfish had about 256 grams per 100 square meters, and nearly 7 times or 7.5 times that in 2013. So a really remarkable increase in parrotfish, specifically in the southern Quintana Roo subregion. All right, so using all these tools we've seen thus far, uh, so the interactivity of the graphs, the filtering, the column switchers, we've been able to go from this whole data set to this one particularly interesting pattern here found in this one region with respect to the parrotfish. If I clear our filter on subregion, we can see if any other subregions seem to show that pattern that we saw here on parrotfish, and certainly in the southern barrier complex, maybe Cozumel as well. So let's ask one more question before we wrap up this line of exploration. I'm seeing parrotfish increases in at least some of the subregions, though perhaps not all. Which subregions show the strongest increase? So to answer that question, let's go to our bivariate analysis tool, or a tool for any pairwise analysis, and that's called fit y by x. It lives under the Analyze menu. So I'm going to go to Analyze fit y by x and say, I want to look at parrotfish biomass over time, and I want to do it separately for each subregion. And if even if you're a longtime JMP user, you may have never really made use of this by role in our analysis platforms. That just means do a separate analysis for each level or each value of this by variable. So I can click OK. And in the JMP interface, when you want additional analyses out of a tool, you go to the red triangle. I'll ask to just fit a quick line. And so we can actually get an estimate of the year-over-year change on average in biomass for each subregion. So for example, right here, we have an estimate of 28.5 in northern Quintana Roo. So that means 1 year over the next, the average increase in parrotfish biomass was 28.5 grams. So not a whole lot. If we go down to Cozumel, 201.6 grams. So much, much larger. Now, we don't have time to work with these results too much more, but just as a nice tip for even some of you experienced JMP users out there, we might want to collect all of these estimates right here and maybe graph them or explore them in some way. You can take any JMP report table, and if you right click, you can make it into a data table. Or if in our case we have multiple tables in one window, we can make a combined data table to be able to investigate just these estimates a little further. So we can see again, for example, Cozumel, really big increase, maybe slight negative increase in northern barrier complex, big increase in the southern barrier complex, and so forth. I'll leave you to explore that on your own later if you like. But just note that these different subregions have drastically different baselines in 2006 in parrotfish biomass. So if we look at just the data for 2006, which are these rows here, and we go over to parrotfish, you can see, I mean, some it's 363, others it's almost 5,000. So looking at the raw change in grams, over year might not be as fair as looking at, say, a percent increase, because a change of 200 grams might not be that impressive if you were starting with 5,000 grams, but it might be impressive if you were starting at 200 grams. So what we want for this last example is this. We can have the percent increase in parrotfish biomass from 2006 to 2018, the full window of data for each subregion. So we have one row per subregion and its percent increase value. This is pretty different than the format of the data we have here, where it's not one row per subregion, it's one row per subregion per year. Sometimes when we're exploring data, we actually have to reshape our data to be able to answer our question. So in this case, to create this table, I'm going to use tools in the tables menu, which is where you should go anytime you need to actually reshape your data. So under the tables menu, you have things like stacking. So that's going from tall to wide format. or excuse me, from wide to tall format, split, doing the opposite, transposing columns and rows, things like that. So let's use the split tool. And what we're going to do is say that I want the data to be the parrotfish biomass values. And I want to create one column per year. So here are the parrotfish biomass values for 2006, 2009, 2011. I'm going to include subregion as a group so that I ensure I get one row per subregion. And when I'm ready, I can click OK, and now I've reshaped the data to be able to answer this last question that I have. We're not going to use these years of data, so I'll hide them. And now the last thing I need to do to find the percent change for each subregion is use a column formula. And it's very common in exploratory data analysis that what you need to do is actually derive some new measure based on the data that you already have. And column formulas are the way in JMP to do that. So what I'm going to do is right-click on this empty column header and go to New Columns. Let's give it a name. I'm going to call it percent increase. I'm going to tell it that the format should be percentage format. And then under the column properties, I'm going to declare a formula to calculate the values. When I click Edit Formula, I end up in our formula editor. And so what I can do is take the 2008 value minus the 2006 value, take that and divide by or scale by the 2006 value to get the percent increase over the 2006 baseline. Oop, I put this in the wrong spot. Let's get that moved down. And there we have it. Now let's finish this off with another quick graph. Take a look at the percent increase by subregion and maybe make a quick bar chart. And if we order it, we can see pretty clearly that actually Southern Quintana Roo and Cozumel show the largest percent increase in parrotfish biomass across this time period than any of the others. Cozumel had a really big raw increase, which we saw when we were doing those quick and dirty regressions. Southern Quintana Roo, however, despite being smaller in biomass overall, is showing the most remarkable increase. And maybe that's something worth following up on. What happened in that region? What might be driving that? What can we learn? But to zoom back out, over the course of about 25 minutes or so, we started with this raw data set. We used a variety of JMP interface features and foundational tools to screen the data, make some data exclusion decisions, make some basic graphs to start looking at changes in biomass over time. We were able to iteratively find our way to a particular subregion or two of interest in a particular type of fish, that is the parrotfish, and then able to assess changes in that parrotfish biomass across subregions and quantify them in a couple different ways. This was all using stuff that we'd probably teach in an intro stat course. And what is particularly important here is just how quickly and easily you can do things like this, leveraging JMP's interactive interface. Again, the thing that makes JMP such a strong tool for teaching exploratory data analysis and really for doing it out there in industry as well. So that's where I'll leave it, and we can start opening up to Q&A. And before we do, I'll just remind you that you're all going to receive a link to the recording of today's webinar and also where you can download all the JMP files that we've taken a look at so you can actually work through them yourself. But with that, Kevin, have we had some questions come in that we can address?
Ross, we have not. But
All
again,
right,
we'll stay here to address some questions now if you have any.
Okay, I see one that came in. How would we get this in a nice report? So I'm interpreting that to mean, how could we get this, all the different things we did, out into a report in a high quality format? The easiest way to do that, let's just pull up an example. So here we have that graph that we made in Graph Builder, is to just copy paste it, honestly. So in a graph in JMP, you can right click and just go down to copy graph. And then in something like Word or PowerPoint, just paste it in. Now, I recommend pasting in a high quality vector format. So actually use the paste special option and choose, if you're on Mac, choose PDF. If you're on Windows, choose EMF, and that'll make sure that as you increase its size, it never gets blurry or pixelated. So copy paste is really great for jump tables or graphs. You can also just go to File, Export, and that will export your graph or analysis report as a standalone file as well. And you can choose the file format.
Oh, Ross, I just thought of something. Can you show folks where the enhanced data sets are? And the reason why I bring that up is I almost want to say the first 10 or 12 of them are only doing exploratory data analysis, visualizations, and summary statistics. So they're good ex data sets if folks want to kind of incorporate what you've taught today.
Absolutely. Yeah, so I just Googled jump enhanced data sets. You can also find them at jump.com/teach. So each one of these is a data set that comes with documentation and suggested exercises. So let's just take a look. Actually, let's see if I can find it here. There's the basketball one. I do enjoy this. So NBA basketball team performance. So I'll click download and save that to my desktop. And so it downloads a zip file. Let me open all this up for you. So here is what I just downloaded. Each one of these data sets, oh, got lots of stuff to minimize, comes with a docx and PDF format of the documentation for the data set. So here we have a problem statement, we have a data dictionary, and then suggested exercises. And this is just exploring NBA basketball team performance. So you have wins and losses and points scored, points against, and a number of other statistics as well. So this is one of many. Hats off to Kevin for putting all of these together. Again, these are called our enhanced data sets. You can find them on our website, jump.com/teach, or just Google jump enhanced data sets. And these are a great basis for EDA exercises with your students.
And someone's asking if you just review the foundational tools for EDA, and I think from my perspective, so much of this is just done within Graph Builder, though there are other tools for sure, but I feel like Graph Builder just dominates this.
Yeah, the big one is Graph Builder. So here we'll walk through again just briefly. Let me find my parrotfish data. Here we go. Nope, that's not the one here. I'll just use the button. Yeah, so we saw a number today. I mean, here we go. This is 6 tools in total. The biggest one is Graph Builder. So this is just your drag and drop graphing, as we did before. Pretty easy to start making some pretty robust or information-rich graphs. But then just to quickly highlight the others we saw, analyze distribution. That's just univariate statistics and graphs. It's where I put every brand new data set before I do anything else with it. All the variables go in the distribution platform. That's how we learned that for some of these subregions, we didn't really have very much data. Tabulate. This is just custom summary tables, cross tabulation tables. When you want to quick and dirty, how many, you know, what's the average number of sites measured for each subregion? This is a great way to answer that question. We also did fit Y by X, just any pairwise analysis that you might want to do. And then we also talked briefly about reshaping tables using the tools in the tables menu. So when your current data format can't answer your question, you can reformat your data. And then the column formulas, the last one, is just one of the many things you're going to find when you go to the column info in any column. And there we used it to, again, compute that percentage change, which wasn't part of our raw data.
Russ, I just want to kind of add a comment for folks. When you really get into taking advantage of the data filters and the column switcher, what you're going to find is in other applications, especially if you're in a programming environment, you have to create a separate graph for every unique combinations of the data. And what you'll see in Jump is if you create a master graph, I like to call it, and then set up all of these filters and column switchers, that tool could sort of create thousands upon thousands of thousands of different views. And you don't have to create thousands of different graphs. You just go in there, switch variables, filter out, as Ross is doing right now, and you'll see it saves so much time. And just the management of your work, you'll see it's so much smaller than if you're in a programming environment. And I think that's where Jump really stands out.
Certainly. Yeah, I really neglected to drive that point home when we were looking at this particular graph. So we started out by just making a simple line graph, but then by adding a filter and a column switcher to it, I mean, the possibilities, I mean, they're not endless, obviously. They, have an upper bound, but the number of configurations between these two tools you can invoke to be able to answer a specific question is really quite something. And to be able to make, I mean, imagine trying to code each of these individual graphs from scratch. You'd spend all day attempting to do that, where in Jump it might take you 1 minute to be able to dial up a tool like this.
Yeah, and you know what I've done in classes, for those of you that are instructors, is I'll work with a data set like this that just has, again, thousands of different views, or maybe if it's just dozens, I'll reduce it to that. And what I would do is I would assign, if the class had different groups or teams, I would assign each group a different variable or a different subset of the data to look at. And then if they were presenting, everyone's kind of got a unique set of data they're going to present. It's all about the same data set and the sort of same application, but then each team kind of is focused on a specific subset of the data. And I have found that's worked really well in classroom environments.
Absolutely, Kevin. Couldn't agree more. Okay, well, let's see. I guess we have a couple more minutes. We can wait to see what else comes in.
Oh, someone asked about AI. I wonder if it's squeeze
Yeah, I was
the chat
typing
box
an
there.
answer to that one. Yeah, so asking, I think the question is essentially uh, if there's some kind of AI summary of the data discovered or, the discoveries of EDA. If you go to marketplace.jump.com right now, you can find a tool called the Jump Assistant, which will perform analyses and graphs based on natural language prompts. But at this time, it's not, I don't know how it would respond to a prompt, find something interesting in the data or discover something in the data like that. It still requires a more directed prompt.
Yeah, I found I've used it when demonstrating it, Ross. I'll type a question like, "How do I make comparative box plots?" Right. So I'm going to quickly get the instructions, and then I might say, "What kinds of features I should look for in the data when examining comparative box plots, or what are some of the challenges?" And it really gives a lot of great guidance.
Yep. Oh, I see another one that's come in. Yeah, traditional EDA uses box plots and stem and leaf. Where can we find those? So you can find both of those under the distribution platform. So let's just take a look at some of the individual fish biomass columns here. And so you can see Jump automatically produces box plots for each of these. And then if you want a stem and leaf plot, you can go to the red triangle and ask for it. So here's your stem and leaf plot right here. So anything that you want to do in a univariate sense, you can do inside that distribution platform. And of course, Graph Builder also will make a box plot. It's a general purpose graphing tool. So if I wanted to go subregion and then maybe let's say we were talking about the parrotfish a lot, and let's make box plots for each subregion for the parrotfish, you just select the little box icon right there and you have it.